Any questions you had
Um,
from the homework before we start doing that test review or the
Not right
discussion?
now, but maybe once we're going through it, I might have a couple questions.
Yeah,
Okay,
same. I don't have any questions right now. I just kind of wanted to see what you would talk about, so I just decided to hop on this.
sure. No, this is great. So if you look at a lot of the exams from previous semesters and you look at chapters 7 through 9, there's really only a certain number of types of problems, right? And if you look at the formula sheet, it kind of gives you a hint too, but um, pretty much we do inference with one proportion or two proportions, one mean or two means, and then I guess paired data is in there too. And then we do a little bit of inference with deviations. And if you look at my exams, the most we do over that deviation stuff is mostly just creating a confidence interval for the variance or standard deviation. So primarily, it's going to only be a small number of problems similar to this. And as long as you can get good at identifying what type of situation you're talking about, so there's really only 3 questions you need to ask yourself. So if you want to write these down. So the first question is, am I doing a hypothesis test or a confidence interval? Many of these problems ask you to do both within it, right? Which I think is good. Second question you ask yourself, am I doing proportions, means, or deviations? And hopefully the scenario makes it pretty clear on that. And then all you're looking at is, do I have one sample or two samples, or potentially paired data, which is the same people being tested twice. So if you can answer those 3 questions, you can navigate which things to do in StatCrunch. You can navigate, if you wanted to go through the formula sheet and find the correct formula for that. So for instance, on this first one, if you can look right away, you see we're talking about percentages. So what's that just tell you right away? We're doing inference with what? Is it means, proportions, or deviations? What do you think?
Proportions?
Yep, that's it. Good job. Let me see here, go back to this. Okay. Oh no, did I mess that up? Hold on, I'm sorry. Well, let's try this again. Maybe I select, sorry. I just clicked, oh, there it is, duh. Okay, just gotta toggle it, good. So yeah, so we're talking about proportions. So in this scenario, suppose minorities are 29% local population, local business has 125 employees, 28 are minorities. Did the business discriminate? As essentially, is the number of, is their proportion significantly lower than the group that it's drawing from? This is very similar to the discussions we've been talking about and everything. So this is in line with that. So our null hypothesis is always equal. And we're talking about proportions, so we're going to use P, that's population proportion. So we're assuming that the population proportion is 29%. That's kind of given to us. And now we have this local business, which would represent a sample of that population. And we're trying to see if it's different then. Now, if you said, and this one I had the alternative, is that it's not 29%, because it could be disproportionately high or it could be disproportionately low. If you wanted to make it one-tailed, like just look to see if it's disproportionately low, that would be fine as well. You can make it a one-tailed test. I'm not going to be picky on that. And then you can do your z-score. Now, you can go right to StatCrunch and go stats, proportions, one sample with summary, and go ahead and do it like you've done your homework. That's fine. And you will, or you can write down the formula just to make sure, just in case you made a clicking error on StatCrunch and you got the wrong z-score here. Or you can write it all out this way. If you just had essentially the test statistic, which is the z-score is negative 1.63 or something very close to that, I'm going to give you credit. And then, but if it was off, but you showed me that you used the correct test, I would probably give you at least half the credit. You'd only miss 1 point there. And then based off that, StatCrunch will give you a p-value. So if you look up negative 1.63 in your in the Z calculator, you get 0.1039. I'm sorry, 0.052. If it's two-tailed, we double it. Sorry, I'm using my pointer here, right here. So since it's two-tailed, we can double the p-value. If you did a one-tailed, that's fine. You can say I'd accept 0.052. And if we're gonna, and notice I don't give you an alpha level on this in this part. Down here, it says use it a 0.05. But usually I'm not going to get too picky, because what we should be looking at is, what is that? What's the probability of observing this result by random chance? Well, we got about a 10% chance of this happening by randomness. Is that rare? Kinda. Is it super rare? No. So this is where you have to have kind of a judgment call. Is this statistically significantly low? Well, if we use the 0.05 threshold, the answer is no, because the p-value is not less than the null. We failed to reject the null hypothesis, so we say p is greater than 0.05. Failed to reject the null. There is not significant evidence to say the employer discriminates. Now, does this maybe lead us to think, it's getting close? It might be. One issue here is that it's only 125 employees, so it's a small number. If it was a larger employer that had the same proportion, then it would probably be statistically significant, because then this denominator would get bigger, which or this number here, this number gets bigger, which makes this smaller. If you divide by a smaller number, it makes this bigger. So you can kind of see how that might work out. And so pretty much then I ask these type 1 and type 2 errors. Type 1 errors are always when we reject the null hypothesis, but we should not have. So in this case, we would say, yes, they are discriminating, but in reality, they're not. That would be a type 1 error. And that's what our alpha level. Our alpha level is the proportion of time, this 0.05 is like the proportion of time that we will make a type 1 error. Because out of all the realm of possibilities, the things that happen less than 5% of the time are possible. But when we observe things that are below 5% of chance happening, we will end up rejecting the null in this case, and we could be wrong. This is why we have to be careful with statistics, that we're not sure if we're right or wrong, which means we could make errors, which is a type 1 error, rejecting the null, but you shouldn't have. And notice you have to say something about the context here. If you just said reject the null and you're wrong, I wouldn't give you credit. You got to say reject the null and say the company discriminates, but they don't. You have to pull in the scenario or the context here. Type 2 errors are when we fail to reject, but we should have. So fail to reject the null and say they did not discriminate, but they really did. And that's another potential error, and that is beta. That's the proportion of time that we make type 2 errors. So this is a very classic, typical type problem I'm going to give you probably right off the bat. After going through that one, what do you think?
So if we do the Z-score through StatCrunch,
Yep.
we still have to write out the formula.
Only if you get it wrong. So if you have the correct Z-score here and you calculate this all right, I'm going to give you full credit. I changed this rule. This is an older exam. You must write down the correct form to get full credit. I just said you write the formula down if you want to get partial credit if you miss it. So that's kind of up to you. Is that cool?
Yeah, that makes more sense.
Yep.
Okay.
So you could straight up do it in StatCrunch, get that. So if you look at how I score this, 2 points for null and alternative, 2 points for the test statistic, 1 point for the p-value, 2 points for stating your conclusion in context, and then 2 points for your type 1 and type 2 errors. Another element I could bring to this is to ask you to make like a 95% confidence interval, and that could be another 2 points, 2 or 3 points. So, and if you make a mistake, let's say with this Z-score, which makes you make a mistake for your p-value, which makes you make a mistake for your conclusion, I take that into account. If you made logical thinking after that error, I give you the benefit of the doubt.
So for the finding the critical value, what formula did you use in StatCrunch? Because I was trying to find the p-value on some of my homework, and I like would get the right answer sometimes, but then like sometimes it wouldn't. Like I don't know if
Yeah,
that makes sense.
those critical value questions are unfortunately still in our homework sets.
Mhm.
That is a dated technique. We
Mhm.
shouldn't be looking at a quote unquote Z-score to
Okay.
determine whether reject or fail to reject. We should just stick with the idea of p-values because that works with every type of test.
Okay.
We're looking at that p-value. So don't get worked up about those critical values.
Okay.
Yeah, I know there's a few of those annoying ones on the homework still, but
So
that will
then
not be on the exam.
the p-value, you need to take it times, you need to double it though,
If it's two-tailed, like
if
if you
it's
made this
two-tailed.
a two-tailed exam, and let's say I'm sorry, two-tailed test, but you didn't double it, I'm still not going to freak out on you. If you just put
Okay.
0.052, I'm still going to be fine with it. I'm especially on the final, I might take a point off on one like
Okay.
that. But for this exam, I'm pretty lenient because I'm like, oh no, they're doing this right. Okay, they get it. Okay, they should have doubled, but that's not a big deal. In fact, the
Okay.
result is exactly the same. I don't get crazy picky on this exam. I'm looking for right thinking, right methods, right
Mhm.
inference, right
For sure.
conclusions based on that. And I'm very happy if you can do this. We just met with Iowa State and UNI to talk about this course. And what we've
Mhm.
realized is our course is actually maybe more rigorous than Iowa State's first course.
Really.
Um, so we're going to be looking at some of our competencies, but this part of it, they said yes, do this, do this, do this. Uh, this is important. If they get this type of thinking, they will be very well prepared if they have to take the next course at Iowa State. If there's another stat course or business stat course, they
Mhm.
have the correct thinking and techniques down. So that made us feel really good. All
Yeah.
right, is that helpful?
Yes, very, thank you.
All right, and when and I would suggest going over some old exams. If you want to watch the solutions videos, that's great too.
Mhm.
Kind of, I don't probably do quite as thorough of a job explaining as I am right now, but you get the
Yep.
gist of it, especially if you've done a couple. So I would even suggest taking like the 2019 exam
Okay.
and just trying it. Just do it
Mhm.
with no help. Just try it. Just get your StatCrunch going, your form sheet, go, try it. And then go back, look at the answers, see where you made mistakes, look at the solutions videos. And if you have more questions, say, hey, I got this on this one. Can you explain this better? I'd love to do that. So
Okay.
that's a great way to prep. Most students who've done that, a few of those exams and done that due diligence do very, very well
Mhm.
because they've done all the homework, they've done this, and actually the exam can be super easy if you've prepared well. And I get some very good scores. And um, yeah, so I can tell usually if there's been some prep work. But just do your due diligence and go through those old exams. And if there's something weird, let me know. Um,
Okay.
and it usually only takes about an hour to take the exam if you're well prepared. I'll give you a 2-hour window.
Mhm.
So it depends on from student to student, but typically well prepared students take about an hour, a little over an hour to do, like, essentially this is what, 5 problems or so, but there's a lot of parts per problem.
And then I
All
also
right,
had a question on,
yeah.
oh, sorry, on our discussion questions, if we still have like old ones that we didn't get full credit, can we still get full credit for those?
Yeah,
Okay.
if they were late, the highest you can earn is half credit. But if you did an initial
Okay.
post before the
Yeah.
deadline and you get full credit, yes, you can go back and get full credit.
Okay.
Yeah, so definitely go back and go through those. Just kind of go through your grade book and see if there's
Mhm.
any not 100%, and especially in your online homework. Let's say you didn't do
Mhm.
a couple, you can still do those for half credit. It'll update. And if it gets to the end of the term and you're on the borderline of a grade, many times I'll go in and I'll look at my math lab and I can see if you've reworked any so that you've got
Mhm.
half credit on. So if it's a 0.5% difference or percent difference, I'm like, okay, let's see if they went back and redid some work, and if that small percentage is a difference maker, then I'll give you the benefit of the doubt. So
Okay.
and
Yeah.
change those. A lot of people, I always get a few emails the night of the deadlines, which is just the way that's the way humans are. And I'm usually like, it's going to be okay. Just do them later for half credit.
Mhm.
All of your homework is worth like what, about 25% of your grade. which makes each homework worth about 1% of your grade. So if you didn't do one of your homeworks, it's 1%. If you make it up half, you're off 0.5% overall if you don't do a homework, right? So
Yeah.
in the big picture, it's not that big of it. I mean, it can become a big deal if you make it habitual, but so I'm like, yeah, don't worry about it. Just do it for half credit. And like I said, if it does make a difference, I will give you the benefit of the doubt if you've gone back and reworked all of it. So
And
definitely
then
go back and do this.
is this our last test before the final? Right?
Yep.
Okay.
And so the last 3 weeks, our chapter 10 is on linear regression, and you also post an idea for a final project. And I think we added that inference with means discussion for the first time this year, and I think that really helped everybody go, oh, okay, this is a proportion scenario. Oh, this is a means scenario. Okay, and a lot of people came up with ideas that could be used for a final project, which is great. And so you're just going to be posting your initial ideas this next week, and really you've got kind of 2 weeks to do that. And then you eventually have to do your project and make a short presentation of your results by, I think, the Tuesday of finals week or something like that. And then you just got to take your final exam by the last day of the class.
Okay, awesome.
And so for students that are, ambitious, they could, kind of be done right at the beginning of finals week, or they could be done at the end of finals week, I guess. So so you have a little flexibility there, because then you're going to see some other students post their videos, their results. Kind of interesting to see what they picked and how they did it. And you'll see errors, right? And I do allow people to go back and revamp their projects if they've gotten them done, before the last, like 2 days before the end of the class. If they've gotten them, if they've done their project and done their presentation, and there's still like 48 hours left in the class, they can go back and redo them to improve their grade. And I'll put comments on things they need to redo. And you can do that obviously ahead of time too, but I allow students to get another shot at that. Cool?
Sounds good, yeah.
All right. Well, how about we just keep going on a few more of these? That sound good?
Sounds good.
All right, number 2 is, if you look, just kind of reading it, has a mean of 14.8 feet. So that kind of tips us off that we're going to be doing an inference of means. Now it does say standard deviation as well, so we got to be, okay, what are we asking here? And it says, based on information to determine if the manufacturer is making rods too short. Make that a little bigger. How's that? Do you know how to make it bigger on your end? There's a little plus, there's like a magnifying glass in the upper left-hand corner. I don't know if you can see that to make it, if you want it bigger. I just did it in mine. So anyway, so here's the work. So we've got our null hypothesis is the rods should be 15 feet long. So mu equals 15. The alternative is that mu is less than 15. See if they're too short. Here's our test statistic, x bar minus mu over s over the square root of n. And you could use StatCrunch to get that, negative 1.23. You look up that on your T calculator, and you get 0.1188. That is, I think we had a threshold of 0.1 was the alpha level on the other screen. So since it's greater, or no, if you just used your table, the best your table would give you is that P is greater than 10%. But I would just suggest using StatCrunch, get the exact p-value. And then it's greater than 0.5, failed to reject. We don't have significant evidence the rods are less than 15 feet. Now, the average was 14.8, but that could just mean we had one bad rod. We're looking at the average of a group of rods. So essentially, can we throw out the whole batch? We don't have quite enough evidence here, but we only sampled 16 rods. So this would lend me to think, you know what, maybe we should test more rods and see if this is really a pattern that's going. And then this one, I ask you to do a confidence interval. So there's the formula for the confidence interval. You wouldn't have to do that. You could just go right to StatCrunch and go ahead and find this confidence interval. So we're 95% confident the mean rod length is between 14.45 and 15.146. Then, and of course, 15 is in that interval, kind of confirms that, well, maybe the the average is 15 or more. We don't have enough evidence to refute it. But if you showed this formula and this work, I could give you partial credit. I did make that part 3 points. And then the extra credit I did here was a confidence interval for the variance. And there it is right off your formula sheet. You could go right into StatCrunch and use confidence interval for variance. The key thing here is I think I gave you, I'll go back through, I give you the standard deviation here, I think. Yeah, I give you the standard deviation is 0.65, but it wants an inference for the, this formula requires you to start with the variance. So you have to square it. There's the standard deviation. So there it is, 0.65 squared. There's 16 minus 1, that's degrees of freedom. These chi-squared right and chi-squared left come right off the chi-squared table. Or what I would do is just go to StatCrunch, do a confidence interval for variance. They're going to ask you for N, they're going to ask you for S, they're going to ask you for the level of confidence, and boom, it's going to give you this 0.23 to 1.01, but you're going to have to realize, oh, but I want it for the standard deviation, which means I need to take the square root of everything. So really, I'm 95% confident that the true standard deviation of the odds, the variance or the variability, standard deviation is between 0.48 and 1 feet, which is a lot. That's a lot of variability. So this is probably not quite an accurate scenario, but you get the picture. So that's another way. Instead of asking for type 1 and type 2 errors, I might do confidence intervals. I did make this one extra credit as well. Questions on that one?
Nope.
No. Sounds good.
Okay. Cool. Have you already looked at these before or not?
I looked over them earlier, a couple of them.
Okay.
I don't know if this exact one, but
This is the 2021, so just so you know.
okay.
And then this one is, it actually gives, I actually gave you the formula because it's an inference between two proportions. I was very explicit. Because we had two samples, we have 250, so 146 out of 250 and 103 out of 202. And I give you the sample proportions right there. So your null hypothesis is that the proportions are equal. This is men and women vote, the proportion that vote for Republican is equal. That's your null. The alternative is that it's greater than with men. And so it's 58% for men and 51% for women, which is about a 7.4% difference. We do the analysis here. We get 1.575 for our z-score. You could, again, use StatCrunch with proportions, two samples with summary. You can just put those right in. The p-value is 0.0571. That's a little higher than 0.05, so we're going to fail to reject again. There's not enough evidence to say that men vote at a higher rate than women. Now it's close, right? So this might lend us, if I was actually trying to figure this out, this would probably say, you know what, let's do some further study here. Let's get another sample or a bigger sample and see what trends we see. But based on this, it's not statistically significantly higher, even though it's higher. Cool?
Cool. Sounds good.
Kind of getting the pattern here?
Yes.
Yeah. And so hopefully you can tell right from the context, means and proportions, pretty much as I got to figure out one or two samples, and away you go. And this one is a little different because it's got paired data. It tells you that the average difference. So this is like the same, a person takes a pre-test and a post-test. So like I could give you a pre-test before this office hour and a post-test after. Same people being tested twice. We're seeing, is there a statistically significant increase or decrease, difference, right? And I'm telling you right now, the average difference is negative 1.125. So it lowered, I think it's the anxiety level. Is that what it was? Yeah, anxiety levels before and after this training or whatever it was. So our null hypothesis is that the mean dependent data or mean difference is 0. The alternative is that it's less than 0 or that it's gone down. It's one-tailed typically. And then I'll go to the next sheet here. And there's the t-stat. D bar is the average difference, and there it is. Their null hypothesis is at 0, standard deviation again, you could do this on StatCrunch. Stat means or T-stat with paired data with summary. And we get negative 3.92, which is 0.0006. So that is statistically significant. We can reject the null hypothesis and say that it did lower anxiety right here. Reject the null and say we have significant evidence that training lowers anxiety levels. Then I did a confidence interval here. Again, just in StatCrunch or write the formula down right off the formula sheet. So we're 95% confident the true mean difference, the lowering, is between negative 1.74 and negative 0.51. Both of those are negatives, which tells me 0 is not in this interval. It reinforces that it does lower anxiety levels. And then, yeah, so here would be the explanation. We're 95% confident the mean difference in anxiety levels is between those two numbers. So that's a little trickier, I would say, but hopefully you can see this like terminology right here. It says mean difference as paired data. Does that one seem familiar? That's from the kind of the last section we did last week.
Yep.
Or does that look familiar to that last section?
Yeah.
So if you didn't get all those done or whatever, I would just encourage you to go back and just do a few of those to prep. And yes, use StatCrunch, okay? And this last one, yeah, this is it. This is the last one. Is this one I kind of gave you the T-stat and p-value. You didn't have to do any calculation. It's just inferring, which is typically what, if you're consuming statistical research, you're just gonna be given this stuff. You have to make inference on your own. So the null is that the averages were equal between company A and B. There's two companies, which means they had two samples. And instead of doing a difference of two means, t-score, there it is. It says negative 4.77, which gives you a p-value. What would be the associated p-value? If you look up negative 4.77 on your t-stat, you're going to get about 0. All right. So these toothbrushes are not the same. So we can reject the null hypothesis and say there's significant evidence that company A toothbrushes less compared to B. Because the average was 117.7, the other was 120.6. So that was statistically significantly less. So company B has a little better toothbrushes as far as longevity. So I might be getting, if you look at some of those, and sometimes I'll say, here's the p-value. Tell me, what does that mean? You know, oh, we reject, and here's the result. Or we fail to reject, and here's the result. How's that look?
Good.
So honestly, there's really only about 4 or 5 different kinds of problems to study for, isn't there?
Yeah, which is helpful to know.
Yeah, means and proportions, one sample, two sample, maybe paired data, confidence intervals, hypothesis tests with those as well. Type 1, type 2 errors. Can you tell me what the type 1 error would be for number 5? Anybody want to give it a shot? What's the type 1 error for number 5? Potential type 1 error. So remember, a type 1 error is when we reject the null, but we should not have, right? So what does it mean if I reject the null here? What does that mean in context? Which is what we ended up doing here. We reject the null and say what? We have evidence, company A toothbrushes last less than company B, right? But if it was a type 1 error, we'd say, yep, reject, they last less, but we were wrong. That would be a type 1 error. The probability that we're wrong is just about 0, but we could be wrong. Type 2 error is when we fail to reject the null and say, nope, they're the same, but they actually was a difference in the length of the tooth, the length of how they worked, longevity. So you can apply that to pretty much any problem. Type 1 is when you reject and you shouldn't have. Type 2 is when you fail to reject, and kind of explain what does that error mean in context. So I would just practice those on your old exams. Cool?
Cool. Sounds good.
So anything else that seems pressing or that might help as you get ready?
No, you think it would just help to go over the old tests and try to take
Yep.
them? Okay.
Yeah, try to take them, try to simulate an exam.
Okay.
Like give yourself a time limit. Sit down, pull it up in your screen and start writing out your answers. And then go back and look at the solutions. And you'll know right away if you did well or if you got stuck. And if you do that a couple of times, if you've done all your homework, you're going to do excellent on this test.
Okay.
Should get an A if you've done all the homework and you've gone through all that stuff and you go through the review. Typically, students get an A on this test.
Do you know what chapter was the type 1 and type 2 in?
Yeah, that was in chapter 7.
Okay.
It talks about that just in general about let me see here if I can go back and dig through the course here if you want. There's a few in your online homework. Let's see here. Let's go back to it's when we started talking about hypothesis testing. Let's see here. It might be an 8.1. Let me check. See if I can find one there. Let's see. All right. Let's see if I can find one here. Let's see. Not that one. Let's see if I got this one. Yeah, digging through this homework. Sorry, it's going to take a little time. So I'm in section 8.1 right now, and that's like you're doing just kind of conceptual understanding of hypothesis testing there, and trying to that's typically where you're going to find. There it is. Let's see here. Question 9 is an example. It says identify that type 1 error and type 2 error that corresponds to the given hypothesis. The proportion of people who write with their left hand is equal to 0.22. Okay. So the null hypothesis is that it's 22%. The alternative hypothesis is that it's not 22%. So a type 1 error would say we reject the null. It is not 22% of the population, but it actually is. Type 2 error would say we fail to reject the null hypothesis. We say that it is 22%, but it's actually not. So there's the example. So probably question, so 8.1, number 9, number 10, number 11. Yeah, there's 3 right there. So questions 8, 9, and 10 on section 8.1, if you want to go back and review those. Great question.
Okay, perfect. Thank you.
That's a great idea to go back and take a look at those. Yeah, I probably overemphasize it, but it seems relevant because we need to be aware that we could make mistakes when we're doing statistics, right? There's potential errors, and we need to understand if I make an error, how big of a deal is it? So when I make an error in a court of law, in a criminal court, it could mean someone's freedom, right? In a civil court, it could mean someone's money. Those are different things, right? Or if I'm dealing with a some kind of a drug, it could hurt, it could hurt somebody. So there's different scenarios that require different cautions when it comes to type 1 and type 2 errors. But if you come up with a better process, you can actually lower both type 1 and type 2 errors. So usually if we increase alpha, beta goes down. So for instance, a type 1 error in a court of law is when we say, we reject the null. We say you're guilty, but you're actually innocent. That's a type 1 error. Then a type 2 error is when we say we failed to reject. You're innocent, but you're actually guilty. Let's say I don't want that. I want fewer type 2 errors. I want fewer guilty people walking the street. So I'm going to lower beta. I'm going to lower type 2 errors. But what will happen is type 1 errors will increase. So if I make sure it's an easier standard to convict someone, there's a better chance that I'll put an innocent person in prison, which is why in the United States, our null hypothesis is innocence, which means we're going to have very few type 1 errors and probably quite a few more type 2 errors. But if we have a better process like CSI or something and have less variability and better data and more accuracy, we could actually lower both at the same time. Is that helpful?
Yes.
I don't know, it's the best example I can think of. So, yeah. And that's why I think that's why a lot of mathematics teachers sometimes don't like teaching statistics, because it's not a hard and fast rule. You are always setting yourself up for making a potential error, but you have to think about it that way. This is the way it is. I actually enjoy that kind of thinking, which is called statistical thinking. It's a little different than mathematical thinking. So, which is why this course is a little different than other courses. It's more of an inference and analytics and determining what do we think is going on based on the data that we're given. So, all right, I've droned on enough probably for you, haven't I? I really enjoy teaching stats. So I'm very thankful when students request an office hour. So thank you for being here today, okay?
Yeah, thank you so much for taking your time to help us too.
Yeah, anytime. If you want to do it again, even because the test isn't due until next Tuesday, if you want to do it between now and then, I'm more than willing to do this again. If you come across some things, I will post this recording. So hopefully this will help some people. And yeah, I'm excited to see what everybody's projects are going to be.
Thank you.
You bet. Have a great day.
You too.
Bye.
Bye. Talk to you later.